Good afternoon. This panel it's good to understand that technologies are good if they're used properly, and we would like to discuss the proper use of herbicides and proper management of herbicides. So the first presentation will be on the drift due to misuse of technology in the United States. The second presentation, the growth, the increasing use of herbicides in the soil that create different molecules. So we'll give the floor to George so he can give his presentation. Good afternoon. My Spanish is quite poor, so I will give the presentation in English. I'm sorry.
To be here this afternoon, and thank you for showing up. It's a long day, I realize, for many of you, so I appreciate you being here. I wanted to give you just a very brief introduction. I'm with the University of Illinois, and we have 3 missions at our university. We have teaching. We also have research. We have the oldest experiment station in the United States on our campus, the Morrow Plots. And then we also have extension, taking the information from the research base and providing it to farmers all over the state. And that's my area that I worked with as Director of Extension for the state. One of the things that is very important to us is that we are connected. We have a land grant mission to take the research and make it available, and so that's what we work on. I wanted to provide a little background about Illinois and our crops that we grow, if you're not familiar with it. So we have about half and half corn and soybeans. We have approximately 4.5 million hectares of corn, about 4.5 million hectares of soybeans. We have a little bit of wheat, 238,000 hectares, and about 190,000 hectares of hay that we harvest. So mainly corn and soybeans, about half and half. The problems that our farmers are facing, the challenges right now, I'm just going to talk about 3 of these very briefly. First of all, resistant weeds is a huge issue that many of our farmers are faced with, and I think you also have problems here as well, managing herbicide-resistant weeds. We also have problems with pesticide drift, with herbicide drift this year and also last year. And that's the topic that I'll spend most of my time on this afternoon, is looking at that issue with dicamba and some of the problems we had with it drifting off target. And then finally, if we have time, I'll touch on some water quality work. That's another big issue that our farmers are faced with, regulations over how they apply fertilizers and what is allowed. So that's a quick overview. Again, if we start with herbicide-resistant weeds, we currently have about 27 different weed species that have been identified as resistant to herbicides in Illinois. The ones that are very problematic, one in particular, is water hemp, and it's resistant to multiple different herbicides, multiple modes of action. And so in 2009, we identified a species or a population that was resistant to 4 different herbicides. In 2016, we found a population that was resistant to 5 different herbicides, different modes of action. And so the real issue is, how do we manage these weeds going forward? We also have another weed that's causing problems, and that's Palmer amaranth. And this is a weed that's just come into the state, and it's very aggressive, and it causes extremely high yield loss. So that's some of the challenges that we have. As a result of the herbicide-resistant weeds, a herbicide was labeled for use on dicamba-tolerant crops in 2016. and it's very effective in terms of controlling some of those weeds, but we had some problems that showed up. Several different companies market dicamba that has a lower volatility, but we still had issues with damage to adjoining soybeans. It was widely adopted, it was widely planted, farmers see the value of it, but yet if the soybeans are not herbicide resistant, we had drift showing up over a widespread part of Illinois and also around the Midwest. If we look at how that damage occurs, there's several different routes for this to occur. We can have physical spray drift, where the particles themselves are moving off target. We had some issues of tank contamination, where sprayers weren't properly cleaned out after applying Banville or dicamba. And then the third one is probably the most challenging one, and that's the movement due to vapor phase after it's been sprayed, and that's where we see the biggest challenge going forward. We had some other issues with temperature inversions, where warm air was trapped between two layers of cold air, and the herbicide particles moved a lot farther than they normally would. And so those are some of the issues that we deal with. Looking at, again, those different types of drift and different types of issues. This is just particle drift, where the field was sprayed, the wind was blowing in the wrong direction, and it carried the particles onto an adjoining field. Spray tank contamination is another issue, where the tank was not cleaned out between loads, and we had some problems with adjoining fields being damaged. But the one that is really the most challenging is volatility. Dicamba, as many of you know, has a history of volatilizing under conditions. Kevin Bradley at the University of Missouri did an experiment to try and understand that. And what Kevin did is that he applied different herbicides, and then he came in after the fields were sprayed, and he put pots of soybeans in those fields at different times. And so, to go through the results very quickly, what he found when he put the plots, this graph shows visual injury 21 days after application. This shows the time that he put those pots in the field. And call your attention over here that even 24 to 72 hours after spraying the herbicide, there was still volatility coming off the ground and enough to damage the soybeans that were used as indicator plants. And so this was an issue in 2017. It affected a large number of acres. They estimate 1.5 million hectares of soybeans were affected by drift from dicamba being used. And they estimate that the number of complaints that they had were extremely high. In Illinois, our Department of Agriculture monitors the number of complaints, formal complaints that the state receives. And as you can see, going back to 2006, the number of complaints were fairly low, about 100, and then 2017 they jumped up. The green bar is total pesticide complaints, the red bar is agriculture related, and the blue bar is specific to dicamba. So last year that was a large, the biggest share obviously in terms of what the formal complaints that our Department of Ag received. It was very clear to see in the field soybeans that had dicamba tolerance and those that did not. And it was uniform over the whole field in this case, looking at probably a volatility situation. Our fertilizer and chemical dealers are also very concerned. They conducted a survey last year and asked the question, if you applied dicamba, did you experience any instances of drift or damage to nearby soybeans? As you can see, the numbers were over 80%. It was a very large percentage, a huge percentage of those that was applied. They also asked the question, how concerned are you about this going forward? And as you can see in this graph here, it says that many are extremely concerned. That's over 60%. And you can see that down here, everyone has some level of concern going forward. Now, one of the things that happened as a result of 2017 was that the EPA changed the registration. They made it much more restrictive. They added a number of restrictions to the label, one being that the applicators had to go and be a certified applicator even to use it. They had to attend special training. They required farmers to maintain a lot more detailed records. They limited applications during times between sunrise and sunset, and also reduced the wind allowance for trying to reduce that drift from occurring. And there were several other requirements that also dealt with cleaning out tanks. So they really tried to tighten the label in 2017, in 2018 rather, going forward. The training that was required was offered all around the state. Over 11,000 people participated in the training. If they couldn't attend, there was also some online training that was offered by several of the companies that provided this as available to people to train at their leisure. So this was a concerted effort to really try and reduce the amount of damage that was occurring from drift. If we look at the current problems, unfortunately, it really hasn't changed. In 2018, as of this slide, it was 275 complaints. I checked this morning, and they're up to close to 300 complaints. And so the number of issues has increased. The dealers are very concerned about what the next step is. What will this look like going forward? And so this is clearly an issue that is on the minds of a lot of farmers. It's unfortunately dividing some farmers that see the value to this herbicide and see it as a very effective tool. Other farmers that don't choose to use this technology or apply it, they're having some real problems in terms of disagreements and lawsuits that going forward. So it's clearly something that we're paying very close attention to. The US EPA will make a determination on November 9th whether or not they're going to continue registering this product going forward. And the options are either to cancel the product, to keep it as it's currently labeled, or to make some modifications. And so most of the people that I've talked to feel that there will be some changes to the label, but again, the number of complaints that occurred was higher than last year, unfortunately. So this is one of the things that as we look at going forward, again, there's specific markets. In the US and in Illinois, we have farmers that grow organic soybeans, and they receive a premium for not using any pesticides on that field. And that's the area that's probably going to be the most contentious, because again, if we have drift onto a field and a farmer loses that premium for paying for organic products, that's going to be an issue. The other thing that we're struggling with in Illinois, Argentina is much farther ahead in terms of adoption of no-till, and obviously the Congress is around that. What we're seeing with some of our herbicide-resistant weeds is that more farmers that are currently doing no-till are starting to use tillage more and more to try and control some of these weeds because the herbicides are not as effective. And so again, it really needs to be a systems approach to how we deal with not only the issue of managing these herbicides, but also how we control the increasing number of herbicide-resistant weeds. So one other thing I wanted to touch on very quickly, and this is my personal area of research, and that is the use of fertilizers and nutrients for agriculture and how we manage that, and we don't have problems with regulations that prevent farmers from using appropriate levels of fertilizer to grow their crops. Water quality is a huge issue in the Midwest, and especially in Illinois. This is just a magazine article. It reads, "Ag must quickly improve water quality practices or face regulations." The fear is that if agriculture doesn't address this individually or do something on our own, that there'll be very severe regulations that are enforced that will prohibit the use of certain fertilizers or limit rates or be much more restrictive. The issue, of course, with nutrients, if we have loss into rivers and streams, it promotes excess algal growth, and we have problems with the biotic life of that particular stream. You've probably heard of the problems in the U.S. and the Gulf of Mexico. There's a hypoxic zone that they measure every year, and that's another issue that, again, farmers are being identified as part of the contributing factors to that. One very recent change, this was just from July of this year. The state of Ohio, the governor issued an executive order to look at reducing nutrient loss to Lake Erie, and they actually had regulations that came out that will set requirements for how farmers can use nutrients on the fields. It'll affect about 7,000 farms and approximately, about a million hectares that are going to be impacted by these regulations. So clearly farmers are very concerned about what's coming next with being able to use those fertilizers. In Illinois, very quickly, just to give you some perspective on some of the work that we've done, we have what's called the Illinois Nutrient Loss Reduction Strategy. And this is a very broad coalition of regulators with the EPA. It also includes scientists. It includes environmental groups, farmers, Farm Bureau. And the idea is to try and come up with a management plan to control nutrient loss that's agreeable to the majority of people involved. And it's been very effective in terms of getting coalition. Again, the environmental groups have been present at all the discussions. But one of the first things that we did as the science part of the project was to measure and to document how much nutrients we lose from Illinois every year, and the numbers are really high. This slide didn't come out quite right, but what this shows is million pounds of nitrate, nitrogen, and total phosphorus that leaves Illinois, that comes out of the rivers and streams and ultimately wind up down in the Gulf of Mexico. So the number that we lose, total nitrate nitrogen, is 180 kilograms per hectare. 180 million kilograms per year that we lose from the state of nitrate nitrogen, and we lose 17.2 million kilograms of total phosphorus. So a huge load that's leaving the state. And the idea was, what can we do to minimize this? It's a waste of resources. It's a problem for the environment. And so one of the things that we've done is to form this nutrient reduction loss strategy that includes many practices. I saw one of the other talks at the Congress was using the 4 R's approach for nutrient management. And that's something that we also embrace. We also are doing other practices that include managing how our tile water is handled. Illinois and most of the Midwest is extensively tile drained with drain tiles about 1.5 meters deep that move the water very quickly off the soil. Unfortunately, they also move a lot of the nutrients very quickly as well. So we've been trying to focus on nutrient management. The other thing that we're looking at is the use of cover crops. And I listened to a presentation yesterday about the role of cover crops for improving soil health and improving quality of nutrient cycling. In Illinois, the biggest interest right now for cover crops is to address water quality, because we've seen that obviously it'll sequester, it'll tie up some of that nitrogen and phosphorus and prevent it from leaching into the soil profile into tile lines. So the real value that many of our farmers are looking at for cover crops is really from a water quality standpoint. There'll be benefits for improving soil health and reducing erosion, but there's a lot of interest right now in terms of what we can do to reduce soil loss. I think with that, I'm gonna pause and turn it over to Susanna. And again, I want to thank you for sticking it out here late in the day. I appreciate you being here. But I'll quit there and turn it over to Susanna. Thank you.
Muy bien. Acá estoy. Bien. ¿Así? ¿Sí? Bueno.
Good afternoon. Thank you for the invitation. My presentation will be about factors involved in the behavior of herbicides, specifically in persistence, we can talk about something that since 1998, when I started, I've seen that the approaches have been changing, and I feel that we're facing a problem when we think about resistant weeds versus accumulation in the soil. The ways to say it are changing. We want to control weeds. We have to take into account all the environment-related topics. We need to respond to what happens with the crops and in the rest of the planet. And today, this is not new, but nowadays it is the topic about persistence is very important nowadays. This is related to the follow-up process of herbicides. Here you can see sorry. Okay. When we talk about herbicides, with whichever objective we have, we are referring to what will happen regardless of the way in which we apply it, what will happen with soil. The soil is what suffers composition, transformation, and here we talk about retention, transformations, we know them, and the results of those processes, which we call transport, which can be in the surface, it can be deep transport, or drift when it goes to the atmospheres, as we listened to before. All these are exchanging, all these processes are exchanging. This is we have talked about efficiency regarding the objective. Possible damage is pollution, but when we see this process here, maybe efficacy was really good, the process was controlled, but there is pollution. I call this that it's not a problem of the environment, but it is within the field. If there is a problem with a crop, then we will have pollution, of course. We can say that the components of the fact that the soil is has these processes. We talk about organic matter. It is a center of activity. You can see here there are organic molecules, there are functional groups that give it a certain reactivity. There's clay as well. This will have electric charges which will allow soil to retain, to act as a filter. We have interactions that give it a specific dynamics, and all the microorganisms which define the possibility of those molecules turning into something else. We're talking about molecules that are material for these organisms. They will break them down. We're not talking about molecules that cannot be broken down by organisms. So we ask ourselves, what is happening with a molecule that can be there for a year when it is biodegradable? So if it's retainable, so where is it? Which area is it hidden? Here, I think I will tell you some of my hypotheses, and we have to do some research, we have to prove it, but I think we have to focus more on those things related to the solid area of the soil. It is not organic matter only, it is not only clay, the pH, but it's also related to the porosity, the small porosity I can't work with this. Sorry. So we're talking about this depth. Okay. Thank you. So this is the depth. Very small sizes. Not the water that moves around here. We're talking about this scale, this very small scale. What are those molecules? I'm just showing you some of them. I will not talk about all of the possibilities because this problem has been present for a long time, and it will continue present. So we have to deal with the problematic molecules like dicamba, and in 10 years we will have some other molecules. But this problem, we have to think about this problem and how to solve it. What I want you to see here is these molecules, big molecules. All of them are big. They are large, more than 400 units. But this is a lot of carbons. They are asymmetric, they are complex, and this makes it harder to attack the areas where they are not activated. Oh, sorry. This is what I wanted to show you. These are big molecules, large molecules, they're complex. All of them are rich in carbons, as I said before. There's no inorganic chemical products in nowadays. And so they are biodegradable, potentially biodegradable. Another characteristic that we have to take into account is, look at this model we have here. Within this scale, we have the red part is negative and the blue one is positive. Have a look at this. We have the molecules here. They are not positive or negative density. They have different densities in different parts of the molecule. So the way in which they interact will be conditioned as well by whatever is happening. You can see here all these examples, atrazina, dicamba. Dicamba, maybe it's the simpler one because it has only one area of positive density, but it is complex. What do you have to take into account? Those molecules that we don't want in our water, for example, get to the soil and they can go into the different areas of the soil. That's how we have studied it. These are the residues, the mineralization, when they become carbon dioxide. And look at what I'm showing you here. It's the same soil, the same weather, but what it changed here is the use. In one case, the use is related to atrazina. So there's been use of atrazina and there's been mineralization, more than 60% of mineralization. And in the other case, some kilometers apart, there's another soil where atrazina has not been applied. So what happens here is that these organisms don't meet this molecule and they have to start working with this enzymatic system, but they get to it. What is the phase? Here it is good to remember this one here in the liquid phase. Have a look at how it changes when mineralization takes place. So we're sure that it will be what will be broken down is what it's on the solid phase, what it can be extracted. So we see that there's been changes here, and in this other case, these residues that are not available anymore. And here you will listen to this term. When we talk about this dissipation, we're not talking about breaking down or decomposition. We're talking about disappearance. The liquid phase just disappears. Whatever can be extracted disappears. So when I say that a molecule is not available anymore, phytotoxically available, it's because it may be on a solid phase, but it is not acting anymore, or maybe it's been broken down and mineralized. So the question is, we're saying that these molecules are biodegradable. They have possibility to interact with the solid phase. So how is it possible that something stays in the soil for six months, 9 months? I can't understand it. What are the sizes of these molecules? I measured them, and they're very small. I thought about what a professor told me 10 years ago in the States. He studied how atrazina can stay in these micropores, the sizes of bacteria. They are micrometers. So it will not reach those pores. So maybe we have some areas which are not very available, and they can be concentrated there, and then they can change when there's any alterations, for example. The other factor that we have to have into account when we study persistence are the staples. We have to think about them. It's not always soy or corn. What we verified here is that there were more different from in corn in different areas than the difference between soy and corn in the same area. What you see here is how it was in the present in the different areas. The mineralization was present here, and we will, regarding glyphosate, we will still have to study this topic. And it has to be replaced because it is transformed. You have seen this? I'm showing it to you again because it's very recurrent. Most molecules that we have been talking about have acid behavior, and this is not a general rule for the pH, but because it is an acid, there's a problem with negative charges, but this is not the problem. This is not something that we can ascertain. We cannot say that there's an interaction or a chemical link. But if the soil has a pH of 7, we can say that milazoninone will not be retained as if the pH was 4.0. This is related to the acidity. Another issue is the fact that retention is affected by the amount of water. But when does this happen? When it is about products that don't have a very intense relationship between both phases, the solid and the liquid phases. We can see the absorption here related to glyphosate. In this case, the water content does not affect glyphosate. But when this changes, we talk about a retention of 1 or 2. We can see that the amount can be doubled, the amount retained can be doubled, and these are the rates of retention that take place normally. As I told you before, as regards dissipation, I want to tell you that if we're talking about persistence, we are talking about not the half-life, because this relates to the necessary time that it needs to go through, because the half of it disappears. But we have to focus on this, on the necessary time for the 90% of molecule to disappear. But we cannot ascertain any of this, although there is some information. We cannot know the concentration of these substances that could harm the crops. This graphic shows that. We can see here the amount that could require control, and here we can see the amount where we will be free of it. But when is the time where we can say, okay, we can go ahead with it, that we will not have problems? And I think the most important thing here is the doses. Most products are applied in very low doses. Here you can see the exercise, 75 grams per hectare. And the result is that the remain would be 7.5. But if, in order to control weeds in a better way, we put a bit more, we can see that the 10% that remains, it's 11. So there's a 35% of difference, which may be the area the number that represents. It is represented in this graphic, in this difference here. This is a very technical issue, but I think it's important as well when we're talking about molecules which have these characteristics, as herbicides do, which are bigger and more complex. In order to define retention, we talk about critical micellar concentration, which is related to the affinity with the surface, and sometimes it is reverted because these molecules concentrate together rather than be in tension on a surface such as clay, among others. So this is my other hypothesis that I have to prove that may explain why a herbicide that one would expect to have disappeared, we have high concentrations suddenly in that area. When we start talking about these herbicides, when we say maybe it can accumulate and we can see it in the future, it may be an explanation for this. This chemical explanation may be the cause of this. And if this is the solution, maybe it may be active. What can we do? I don't have much time. We have ways in which we can measure it, but usually we do research. We have some other issues that are doing. We can do trials, and we can have bio trials. I suggest them. They are cheap and they're good, but you have to be very careful because otherwise the results are not useful. And here I want to show you. As I told you before, they are cheap and they are effective because the detector is not a photometer or anything like that. It's the plant, it's the crop. The plant will tell us whether it's present or not. We have to be very careful. There's a lot of literature on this, on how to be careful with a biotrial, and I think this is very important. Whenever you take samples, you take them to the lab, or when you will carry out bio trials, nothing will be more exact than how well the sample was taken from the plant. Here you can see the surface, and we see that the organic matter changes. And we all know that the organic molecules of herbicides will be linked to the organic matter, so it could change the retention. Sometimes I see harm here, but in some others there is no harm. And you can see the variation here with midazolinone. This trial that we carried out in a 12 hectares field, a small field, you can see there how the organic carbon dioxide change. You see phosphorus as well. It was impressive, and the microbiotic activity. When we think about it, we think that this activity will be the one which will break down the molecules in short term, and we found out that it was 3 times more. It may not make a big difference, but when we are talking about problematic crops, this may be different. This may be useful. I think that this is very relevant since this, for example, in this book, Fundamentals of Wheat Science, this author states the reason why it is more frequent that we accept the resistance of herbicides instead of doing all the management in order to delay this process, this adaptation process, make it slow. This is on the literature. It is sometimes it's easier to look for some solutions instead of trying to look for general consensus. Sorry about the time. Thank you.
Thank you. We have now some time for questions and answers. You can send your questions via SMS or WhatsApp. I already have a couple of questions for you, George. How do you think the EPA will react since the percentage of the number of complaints was not reduced, and the economic impact too that the state has had to go through? You know, this is the case regarding drifts.
Very good question. Unfortunately, we really don't know what they're going to do. They were supposed to make a ruling earlier, and they've kind of delayed it. And so I think most people believe that they will make some changes to the label. I don't think they'll cancel it completely. I don't think they'll leave it the same. But who knows? With the EPA, it's difficult to predict. I serve on a science advisory board to the Illinois EPA, and they haven't asked for any input from us. So it's hard to know what the ultimate decision will be.
What about the impact, the economic, the financial impact regarding the last season, the previous season?
So dicamba, we know a lot about dicamba damage and how it works. It's been around for 50 years. If the damage occurs very early in the season to sensitive soybeans, many times they'll recover without any yield loss. The problem is if it's later into the season where they're in the reproductive stages, that's when we have real problems in terms of loss of yield. There's some work that suggests you may even see a decreased viability of the seed for germination the following year. And so the issue is really one of timing. You know, early on, I don't think it's really going to be too much of a problem in terms of yield if it's not severe. But again, as you get into the time of reproductive growth where you have flowering, that's when it's especially sensitive. The bigger issue, I think, in terms of not only yield, but it's how the whole issue is being perceived by the public. And it really does present agriculture in a negative light when you have these problems occurring. The homeowners and the people that grow grapes or have vegetable crops, if their crops are damaged, that could be a much more serious from an economic standpoint, and many of those probably won't recover, and you would see some economic loss.
A question for Susana. Based on this annual renting model, stacking herbicides, question is whether there's a buy-a-trial model or which indicator we could take, as a model. As regards the soil, I understand one of the practical issues is that should be within the contracts that are made. And the biotest, probably there was a high concentration because of an erosion procedure or process. So this could be done by taking samples, just complying with the different precautions. There isn't just a biotest. It's just a practical thing. We can just do it in our own places as long as we comply with the different precautions. That is, the plant has to have light. I mean, sunlight, not artificial light or greenhouse light. And fertility should be provided so that the plant could actually express that damage if it ever exists. But the damage could be there, and we could need probably more time. So when you decide on carrying out biotests, maybe it's manifest 2 weeks later. So of course there are biotest models, but the thing is how you're going to conduct it, and the decision to rent or not rent based on the biotest results. I cannot say anything about that, but probably that should be included in the contract. A question to George, and it's about the participation of organic farming in the state, where there is a mixed model of agroecology that aims at reducing the use of agrochemical products.
Yeah, there are different approaches. Organic is the most prohibitive, obviously, in terms of use of pesticides. The fields need to be pesticide-free for 3 years, and so it's a pretty high bar to be certified organic. Other producers are looking at reducing inputs, either from an environmental standpoint or from an economic standpoint. But in terms of the herbicide drift issue, the real concern are those people that are getting paid a premium for certified organic soybeans that largely exported to Asia. Those are the producers that are going to be really severely impacted because they'll lose that premium. And again, it's a 3-year pesticide-free to become certified. Other farmers that plant non-GMO crops maybe aren't as concerned, but it's the organic folks that are really worried.
And did this comprehensive work about water you mentioned before, whether there is a mixed agroecological model that is reducing the use of agrochemical products, and it's not completely green, but rather a mixed model.
Right, and the interesting thing about water quality loss from nutrients is it's more of an issue of tile drainage. Illinois is really unique because we have extensive drainage, as I mentioned, and so farmers, even if they reduce their fertilizer inputs to a very low level and have very low amounts of fertilizer that's added to the soil, our drainage system is very efficient at moving water through the profile. And so that's why we've taken steps that are a little bit more involved rather than just cutting rates. In many parts of Illinois, the application rates of fertilizers are probably pretty close to where they need to be for optimum yields. But our system, we joke and we say it's a leaky system. We lose nutrients through our tile drainage. And that's been the biggest challenge, is to how do we maintain that drainage system but yet keep the nutrients on the field. And that's why cover crops, as I mentioned, is really becoming much more popular as a solution to tie up and sequester some of those nutrients and protect them from being lost.
And one more question, George. You said that in the ongoing season, you trained 1,000 applicators. How did you How did you organize this training? I mean, such a massive training. Who managed that? Who funded that?
Yeah, that's a really good question, and I have to really credit the industry. The Fertilizer and Chemical Association helped organize that in concert with some of the manufacturers. So Extension provides training for farmers and applicators to become certified in order to use certain products, restricted use products. And what we were able to do is just add that training on to the existing ones that were already scheduled. And so it didn't involve a wholesale new set of meetings. There were meetings that were already planned for people to become certified pesticide applicators, and they just added that on at the end as an option for those that wanted to use dicamba. So again, I credit them. It worked very well. The online training was also an option that farmers or applicators could log on and complete the online training. It only takes a couple hours to do that, and we saw a number of farmers and also applicators did that as well. And that training is still available, so if anyone wants to log in and look at it online, it's entirely in English, unfortunately, but that is available currently still.
Una última, aunque el tiempo se terminó. La cantidad, bueno, aún así hubo deriva, aún así hubo daño. ¿Cuál puede ser la causa que
Which do you think is the cause? Because there was a drift anyway. Which do you think is the cause that actually, what do you think the problem was that then it was impossible to reduce that even further, even though you conducted this training and everything? I mean, there was still drift. I mean,
yeah. So as I understand the question, it was they did all the training, and I've talked to a lot of farmers and a lot of chemical applicators, and some have told me that they followed the training, they followed the law of the label exactly, the weather conditions were perfect, and they still had drift occur to adjoining soybean fields. So I think the problem is really that the chemistry itself, it tends to be a volatile compound, and that's the hardest one to control. They made a lot of improvements this last year in terms of reducing particle drift, the spray droplets moving, and also spray tank contamination. But it's that volatility that is the real issue, and that's one that we have a hard time controlling. So one of the suggestions for modifying the label is to just restrict the time that it can be used to make sure that it's applied earlier in the season. And also, again, you mentioned about not relying just on one product, but having a system where there's a soil-applied herbicide that has some residual, and using this technology not exclusively, but as an option, and knowing when to not apply it after the soybeans are more sensitive.